Hello everybody, I'm gonna start a new tutorial series learning you guys C++. Why C++ and not any other programming language? Because C++ is industry standard when it comes to making games. And I eventually want to make tutorials to teach you how to make games, like 2D games, maybe even 3D games if we get that far, but that's still a long way ahead. And this tutorial series is aimed for people that don't know anything about programming yet, but really want to get into making games, since that's what I'm here to teach you. First of all, we're going to need something that we can write C++ in, and so we need some sort of editor. The editor of my choosing, that's Visual Studio. Why Visual Studio? What is Visual Studio? Visual Studio is a Microsoft app that is a combination of an editor, a compiler, a linker, and a debugger, and basically a compiler that transforms your code into an exe so you can run it. It basically transforms what you've written into something that a computer can read. Then you have a linker. What a linker does is if you have external libraries, so you're trying to make some sort of 2D game and you need code that somebody else has written for you, since you don't want to make all the rendering code yourself, then it somehow needs to link that code to your code, since it's something that's not in this, it's not a project itself. So then you have a linker that links everything together so it can build it correctly. And you have a debugger, which is really important, since you're gonna do a lot of debugging. That's one of the biggest things that you're gonna do. But that basically makes it so you can step through the code, you can watch how things are happening while they're happening, and it's just a really handy tool to have. Okay, now the installation of Visual Studio. We're just gonna go to Google and we're gonna search for Visual Studio. Visual Studio. We're gonna go to the Visual Studio website, and then we're gonna download the free version of Visual Studio, which is the Community Edition. So we're just gonna press Download Community 2015. If you're watching this later and there's a different version of the Community Edition, feel free to download that one. Just get the latest one, and the coding is gonna be the same. Maybe the UI is a little bit different, but I'll probably still be around to help you out if you need me. If you ever have any questions, let's get it off of my face. If you ever have any questions about C++ or Visual Studio or anything, I can help you. If you ever want to get a bit further ahead of the tutorial, I can give you some, I can advise you to do certain things. I'm here to help you. Okay, but now we're going to continue with installation. So I've opened the installer and now it's just initializing the setup. Visual Studio is a huge program. You can make so many different things with it. That's why the setup is gonna take a while. It's gonna take a while, especially if you select more things that are normally not there. Okay, since I've already installed Visual Studio, I can probably press modify. Yeah, that will show you what you would normally see. This is what you would normally see if you have not installed Visual Studio yet. All these different things, there are probably a few things that I've added myself in this list, but it basically is good as it is. You just have to press update or install in your case, and that will do it. Then the installation will continue. You're gonna have to wait for a while, and everything will be fine. After that, I want to close the setup. After that, we're gonna open Visual Studio. You can instantly do that after the installation is complete, and we're gonna write some sort of simple program to test if it's working. Okay, we're gonna create a new project, since otherwise we can't do anything. New project is either on the start page or it's under file. I'm gonna do it that way so you can note for later. You can also press on file, new project. That will do the same. Then it's really important that we select Visual Studio, Visual C++, and a Win32 console application. Otherwise we're not gonna have the console and things are gonna be bad. Things are not gonna work the way it's supposed to work. Then we're gonna give it a name. The name that I'm gonna give it is tutorial 0. Okay. Now we press OK. Next. And just finish. You don't have to worry about any of this right now. Just press finish. It will make stuff for you and that stuff will work. Okay. If it wants to work. Okay. So here we are. We are in our first project. So what are we gonna do now? Like if we just press local Windows debugger, so if you're gonna run the program right now, nothing's gonna happen. It's gonna open a window and it's gonna close a window. Nothing much after that. Like it opened a window. Oh, now it's loading some DLLs. It might do that for you too. But as you can see, it's closed already. So first thing that we need to do is #include. That will include a file. Also, it will include something like a header or a precompiled header or something that is already in your system, probably already a system right now. We're going to do include and then smaller than, and we'll automatically do bigger than, and then we're going to type IOStream. Don't worry about what this means right now, just include it so we can make a test program that works. Then we're going to type std, which is a namespace. I'm going to talk all about namespaces in a later episode. cout, which stands for console out. So we're going to write something to the console. Then we'll do a smaller than. That means that we want to push something into the cout, so we want to push something into the console. Then we're going to use the double quotation marks, and in that we're going to type something like hello world, since that's always a programmer's first thing to write, hello world. Then we want to push something else into the console, and that is an std end line, endl, that stands for end line. Also like an enter. Basically I'm now doing an end line. That's the same as typing std endl or doing the /n, like the \n, or the /. I think it's a \n. Okay, and don't forget, always end the line of code with a semicolon, otherwise it's not gonna work, like it's gonna give you errors. And now if you press either F5 or local Windows debugger, F5 is a shortcut for running the debugger, then it will run a program. But as you can see, it didn't even give me time to drag the window from my face over to my main screen. It just ran and stopped. That's because normally code just runs and eventually gets to an end and then it just stops. It doesn't keep the oh god pop-ups. It doesn't keep the window open. But we right now want to keep the window open. There are two different ways that we can do that. We can either press Ctrl F5, which right now the only thing that we need to know is that it will wait at the end of the file, at the end of the program. It would stop and wait for key press. So that's what I've just done. Now it says press any key to continue. Or we can add another line of code called system, then opening with curly brackets, and then once again the double quotation marks, and then we type in pause, and once again we end with a semicolon. Okay, now if you press F5, you will see that it will do the same as it did, only in a different font. Okay, that's annoying, it's a little bit tiny, but if you can see it, it says hello world, and then press any key to continue ... Basically what this does is it's the same, but it will not skip some of the debug things that it would otherwise skip. But if this all worked fine, then there was the first tutorial. Be ready for the next one, it's gonna be uploaded soon. and in that we're gonna talk about probably just functions, how they work, and the different types of variables that you have. Maybe first, yeah, just first the variables, and then we're gonna talk about functions in another one. Basically, we're gonna get you up to speed really quickly. Goodbye. Hello everybody, in this tutorial I'm gonna explain to you the different types of variables that you have in C++. On the top here you have the different types of variables, their full name if they have one, if it isn't already the full name, a brief explanation of what the variable is, and the size of each variable. And then underneath, then here we have a few extra modifiers that you can add before each different variable, and down here I have created a little example of how to use them. After this we're going to go to Visual Studio so we can see it actually in action, but now I'm going to go step for step through all of these different things and explain what they mean. First of all, the integer that you write as int. Basically is a round number, so it can never have any values behind a comma, and it is always the size of 16 bits. Unless you give it a special modifier, but we're gonna go there in a second. The second thing is a float. A float is also really important. Just like an integer, you're gonna use it a lot, and it's basically a floating point value, a number with always numbers behind the comma. Even if it's zeros, it always has numbers behind the comma, and it has the size of 32 bits. Then we have a boolean, which you type as bool, and it's basically a true or false statement, so it's either 1 or 0, it's either yes or no, so it has the size of exactly 1 bit. Then we have a character. A character is basically just a single character, so anything that you can type on a computer. So this is a character, but this is also a character, this is a character, and even the tilde is a character. So they're all just characters, and it has the size of 8 bits, since all of the ASCII things can fit in there. Then we have a string, and a string is basically just a lot of different characters behind of each other. So basically the words or sentences are all strings. And the size of it's unknown because it's 8 bits multiplied by the amount of characters that you have in the string. And then we have a double. What a double is basically a double of a float, so it doubled a float. So it's twice the size of a float. So a float is 32 bits and a double is 64 bits. And the big difference between a float and a double is that the precision of a float is 7 characters behind a comma, and the precision of a double is 14 or 15, I think 15 characters behind a comma. So it has a lot more precision. That's why it's twice the size, because it needs a lot more precision. Now we have the different types of keywords. So we have signed. Basically what signed means is something like a different variable can be both positive and negative. Every variable is standard signed. So you basically never type in signed. Unless you really want to specify and just really want people to know that it can be both negative and positive. Then we have unsigned, and what unsigned means that the value can only be positive, and what that gives you is an extra bit that was normally used to specify whether value was positive or negative. So basically the amount of the highest number that you can store in it is doubled because you have an extra bit available. Then we have a long, and what a long is basically doubles the value of whatever variable you gave it. So a double integer would be 32 bits, and a double float would be 64 bits, and a long int would be 32 bits, a long float would be 64 bits, and a long double would be 128 bits. So never do a long double, it's a lot of bits. And then we also have the long keyword, and basically what it does is it makes it a long, so it doubles it, and it makes it a long again, so it doubles that value. So an integer would then be, so a long integer would be 64 bits, for instance. And now the declaration of a variable. How do you declare a variable in C++? Well, you first specify the type, so int, float, bool, char, string, or double. Then the name, so whatever name you want your variable to be. And then we can also specify the value if you want to. If we don't specify a value, so we just give it a type and then a name, and then we end it off with a semicolon, because that's how you end a line in C++, then it will be just a random value. So it's always useful to at least do type name is equal to 0 at least. So we can also specify a value, and we can also type a modifier in front of it. So for instance, signed, unsigned, long, or long. Here are a few examples. So you have an integer, and I just called it my first int, and here I did not specify a value. This is completely legit in C++, this works, but we can also type it as int, my second int, is equal to 20. This is exactly the same, but now you already gave it a value. Oh. And the third thing that you can do is give it a special modifier. So here I typed unsigned int, my third int, and this is also fully legit. So now it's an integer that can be like double the size that it normally be, because it's unsigned, so it can only be positive. So let's now jump over to Visual Studio and make a project where we're going to type some code. Okay, so we're now in Visual Studio. We're going to create a new project either via the new project in start or file new project. Then it's going to load the window, and we're going to specifically select Win32 console application. This is important, just select that one. And then we're going to give it a name. So I'm just going to call it tutorial 1. Then we're going to go to the application wizard. We're going to hit next. And then we hit empty project. This is important, otherwise you're going to get a few random headers that you can't delete. And it's just a pain. Just press empty project and everything will be fine. Then we press finish. Then it's going to create the project for us, and then we can make a file and we can start coding. So now it created the project. Now we need to add a C++ file, so a file that we can write our code in, and that needs to be in the source file folder. So we right mouse button on source files, add new item, then we specify C++ file, so CPP. If you can't see it, make sure that you selected Visual C++ right here, and then underneath here we can give it a name. So one of the files that is always handy to have, like give it exactly this name, is main, so you know that that's where code starts. We can call it differently. You can start your code from whatever file you want, but it's always handy to have a file called main, so other programmers know that that's the file where the code starts. Okay, then we press add, and it will create a file for us. Now it's opened, and then we can start with our main loop, or well, with our main function. So the one function that will always be called at the beginning of a program is int main, so the main function. Functions will be explained in a further episode, like exactly how they work and how to declare them and all, but this is just one thing that we need right now in order to write code. Okay, so let's now create one of each type. So we're going to create an integer, a float, a bool, a character, a string, and a double. So let's start with int. So we create an int with the name my first int, like that's at least the name that I'm going to give, and you can call whatever you want and it will just work fine. And we're going to specify it as 5. And we end with a semicolon. This is really important, otherwise a line is not closed and it will give you errors. So now we're going to create a float, my first float, and we're going to give it a value of 0.5 since it's a float, so we can give it numbers behind a comma or pointer in this case. But because it's a float, we need to specify an f behind it. This is really important, otherwise it's going to be a double, and that means that it's going to take twice the amount of memory, and a conversion is not necessary because you can also just specify an f behind it and it's all fine. Okay, the next one is a boolean, so we're going to create a bool, bool, my first bool, and we're going to give it either a value of true or false, but you can also specify 0 or 1, but there are special keywords that are basically equal to 0 or 1. This is true and false, literally just true or false. So let's specify this true. And then the next one is a char. So we're going to create a char, my first char, and then we set it equal to, a character. But the way that you specify a character is with this single quotation marks. This is really important, the single quotation marks. So in there we can specify characters, so let's do the T, and then we end with the semicolon. Okay, the next thing, the string. The string, you can't just, if I would just type in string, nothing would happen, like it would not find anything, it will give a squiggly line underneath it. Why is that? That's because a string is not standard, but most programmers see it as something standard. You need to include a special file that contains a string. So at the top of our program, what we want to do is to # or a hashtag include. And then there are two different types of include. You can include with the double quotation marks. That will include something that is inside of the project itself. So either one of the header files, but if you want to access something that's already written by Microsoft, for instance, then we need to use the smaller than bigger than. And as you can see, a whole list will appear with different things, like a lot of different things that you're probably never going to use. But the one thing that we're going to use is called string. So basically just string. And that will include strings for us. But wait a second, now if we just type string, still nothing will happen. Why is that? That's because the string is part of the standard namespace. One of the things that's created for us to separate some different things from the main program. Just in case you want to use something else, it's also called the same name because it's a common name, but then it will give a conflict if it was just always accessible. So they've created something called namespaces. I will explain namespaces in a later tutorial, but the one thing that the one namespace that we're going to use is called std. Remember that name, it's really important. std. And then in order to use a namespace, we need to do the double dots, like whatever they call it, I forgot the name. And now if we type in string, you can see that we can find a string. So we can set it equal to, we need to give it a name, my first string. And then we can set it equal to whatever. But how do we specify a string of characters? Because if we would just type something, it would give us a squiggly line. And if we would use the single quotation marks, it will also give us a squiggly line because it's a single quotation mark is only supposed to be one character. So in order to specify a string, we use the double quotation marks. So now we can type in whatever you want. So let's type in my first string. And then we end with a semicolon. That's really important. Okay, but there's another way to use, to get to string. There is a way that we can just type in string, my second string, and we set it equal to my second string for now. There's another way that this will work. This is possible to work. What we can do is we can say, hey, there's this one namespace that I'm going to use a lot, so I want to make it so I can just access things without typing it out every time. The way that we do that is we type using namespace, because we want to use a namespace, and then the namespace that we want, so std, and then with a semicolon. So what this does is it will make it possible that we can just type in string. You see, no squiggly lines underneath string anymore, but we can still access everything using the namespace. So right now both of these strings are valid. Okay, third thing, a double. So we just type in double, then my first double, and we can set this equal to the same thing as a float. So let's put it at 1.8. But the one important thing is you don't specify the f at the end right now. A double is always just gonna be whatever value without an f at the end, because it's a double. It's something different than a float. Even though it looks like a float, it's internally different than a float. Okay, and these are all the different types of variables that there are in C++. Unless you also want to, let's also do the one with the keyword. So let's do a long. So we type in long again, and then int. My first huge int. So we can set it equal to a huge number and it will still work. Like this might be 2-bit, but I don't know actually, since it's 64 bits. That's a lot. So this is also work. So now we can run the program using either F5 or the green arrow at the top, and well, nothing will happen since we haven't done anything with the characters yet. Oh, yeah, with the variables yet. But it want to give us an error, if I'm correct. Yeah, it will just close. So the one thing that we can do right now is we can print out all our different things. So in order to print out things, we need to include yet another file. So we do the hashtag include or pound include, and then we include iostream. Iostream is a file that you basically always want to include because it's a really commonly used file. So now we can once again call the std namespace, which is not actually necessary anymore because we used using namespace std. So now we can use cout, right, as cout. It stands for console out, since we're every time running a console, with this function we can print out something to the console. The way that we use this is we push something into the cout, so we push something into the console, and we do that with a double quotation mark, double lower than. So now we can push in my first int, and then it will display the int. And then we can do also a cout for my first float, and it will print it out too. But now if you just run a program, as you will see, or probably not see because, yeah, it closed instantly. The one way around that is using Control F5 instead of just F5, or just a green arrow. So if you press Control F5, then it will keep it open. But wait a second, it says 50.5, but my first int was 5 and my first float was 0.5. So why does it say 50.5? That's because we didn't specify that I needed to put an enter or space or something at the end. So the thing that we're going to do now is use another thing that std includes, and that is endl. So we're going to push something else in to the cout, to the console. It's something called endl, which stands for end line. So we're going to do it with both the int and the float, and then we're going to run it again using Control F5. And as you will see right now, it says 5 and 0.5. So we're going to do the same for all of the different things. So I'm just going to use Control C, Control V in order to copy it a few times and then just modify the names. Okay, I'm going to need another one. So if we now run the program with Control F5, it will show us exactly everything that we've created. So 5, 0.5, 1 because it's true, 1 is true, 0 is false, t because we specified the characters t, my first string, my second string, 1.8, and then press any key to continue. That shows it because we press Control F5. Okay, this was it for the tutorial. In the next tutorial we're going to learn how to do different statements, for instance an if statement, or a for loop, so for, and we're going to learn what we have to put in there, a while loop, and do while loop. I'm going to learn you all of these different things in the next tutorial. So thanks for watching and see you next time. Hello everybody, in this tutorial I'm going to explain to you the different types of statements that you have in C++. So let's dive right into it. The first type of statement that you have is called an if statement. Basically in here you specify something. So I've created a little variable called I, and let's say I is an integer. and only if the value of I is less than 5 we're going to do stuff. Then we have an else statement, so let's say that we have this if statement and I was 7, so it was not less than 5. Then the else statement will be called if we specified that, so then it will do this stuff. But let's say we also want to check then if I is less than 7, because the special case is if I is less than 7, but not is bigger than 5 but less than 7. Then we can call an else if statement, and then we can specify some other values. So right now I set else if I is bigger or equal than 5. I'm gonna talk about these different ways to check too. Then we do stuff. Then we also have a for loop. So basically we create some sort of value. So now I've created another integer. I shouldn't call this I, maybe I should call this j. And this basically, it does whatever you specified in here, how many times you specified it should do it. So basically j starts at 0, and then every time that this loop is finished, j will be incremented by 1. So it will do stuff 5 times. And then we also have a while loop, and basically while this statement is true, we'll do stuff. But if this statement is not true, then it will not do this stuff. Then we also have a do while loop, and basically what it is exactly a while loop, but it's a little bit different because it will first run the code and then check if it should continue. Unlike the while loop, it will first check if it is true and then do the stuff. So basically it's the reversed order. It will first do the stuff and then check if it should continue, instead of first check if it should continue and then do the stuff. And then we also have a switch statement. What a switch statement basically is, you should give it a value. So in this case an integer I, and then you have different cases. So in this case, if I is equal to 5, then it will do stuff and then stop doing stuff and continue with the rest of the code. That was a really quick explanation of all different types that you have. So let's now put them in code. So let's go to Visual Studio and let's create a new project. So new project. I'm gonna call it this tutorial 2, and make sure that it's a Win32 console application. That's really important. Press OK. Hit next. Make sure that's an empty project, also really important. Hit finish. Okay, now that a project is created, we need to create our main file. So on source, create a new file, a CPP file called main. So one thing that we need to include are the includes that we did last time. So once again, what an include is, it's an hashtag include or pound include. Then either smaller than, bigger than, or double quotation marks, depending on what type of file you want to include. So do we smaller than, bigger than, and then we type in iostream, and we do hashtag include string. Then we specify our main loop again, so int main. Don't worry. Okay, now that we've created our main file, we want to do two includes that we also did last episode. So we want to do a pound include or hashtag include, either smaller than or bigger than, or double quotation marks. Then depending on what type of include we want. Right now we want something that's external of the project, so we'll use a smaller than, bigger than. Then we type iostream, and then we also do a hashtag or pound include string. Oh, not stack, string, because we also want to use strings in this example for printing stuff out to the console. Okay, so let's now create our main loop, a main function. So that's, we need to specify the return value first. So in this case an integer, then the name, which is main, and then it doesn't take any parameters. Don't you worry, next episode we're going to talk all about functions, and I'm going to explain to you exactly what to do and how to make them, and what you can pass into it and all. So basically just going to be a full explanation about how functions work. But now first, first you want to start with, what was the first one? An if statement. We want to start with an if statement. So let's first create a value. So let's create an integer, specified with int, call it my value, and let's give it a value of 4. Then we can do an if statement. So if my value, now we have different types of checks that we can do. So I'm going to specify them here in comments. You create a comment in Visual Studio with C++ using double / I think it's called. Then it will be green, so you know that it's a comment. By the way, if my colors are a little bit different than you, that's true because I modified my colors to be a little bit more explanatory to me. So don't worry if it's different, it's just fine. So we have smaller than. Basically what a smaller than is, it is if value is less than. So we have, let's say we have a value x first, after that a value y. So if x is less than y, then it will be true. Then and then we also have bigger than. So if x is bigger than y, if value is bigger than, then it will return true. So only if x is bigger than y. So in this case, if x was 4 and y was 7, then it will return false. And also, if x is 7 and y is 7, it will return false because they're exactly the same. X is not bigger. That's the next thing that we're going to do. Oh. X is equal to y. Yes, it's not just a single is, since that would set x to y. It's a double is that would check if it's equal to. If value is equal, then. So only if x is equal to y, then it will return true. So it will do the statement. Then we also can combine these different things. So x is smaller than or equal. So both values are true. It can be either smaller than or equal to y. If value is equal or less than. And then we can do the same for bigger than. So this will be true if, let's say the x is bigger than or equal to y. That means that it will return true if x and y are both 7, for instance, and x and y, like x is 8 and y is 7, is equal or bigger than. That are the different types of modifiers that you have. So now we can do my value is bigger than, let's say 5. So only if my value is bigger than 5, oh, let's do in this case 3, then it will enter the statement. By the way, we use the curly braces to specify different scopes. And things that you created in a scope are only accessible in that scope or lower scope. So if I'd create a value called an integer called my second value and set it equal to something, then I won't be able to access my second value out here because it's already out of scope, because the scope ends here. After this, everything that's inside of the scope does not exist anymore, except if you specified it outside of that scope. So as you can see, we can still access my value. That's because we created in this scope. And in here we can also access my value because it's created in a higher scope. But we cannot access my second value out here. Okay, so if my value is bigger than 3, then we do an stdc out, but we're going to specify using namespace std. Remember that name from last episode? That's the namespace that's globally used for standard things. So what we do now is we make it so that we can just access that namespace without writing the namespace every time. So now we can do a console out, cout. We push in my value was bigger then 3. And then we push in an end line, so it will give us an enter. And let's specify up here a cout testing if my value is bigger than 3. And then another end line. So now if you run this program with Ctrl F5, remember Ctrl F5? Because otherwise it will just run a program and instantly close it at the end. So now you can see that it will say testing if my value is bigger than 3, and then my value was bigger than 3. So that's great. So let's now do the second thing, an else statement. So we simply just type in else and then do the brackets. So let's do an else, cout my value was less than 3, and then an end line. So now if we change either the value of my value or the thing that we're checking against, it will change the way that the statement works. So now if I say my value is equal to 1 and we run the program again, it will say my value was less than 3 because, yeah, my value is 1 and not 3. So now let's add the third statement, an else if statement. So let's do that in between here, since an else if statement always needs to be after an if statement. It can't be after an else statement, it needs to be after an if statement. Else if my value is equal to 3. Remember the is equal to? That's a double is, not a single is. It's a fault. That's something that's a fault that I've made a lot of times, and it will give no error because it's just valid. You just set my value to 3, but that means that it will always return true because you just set the value to 3. That's legit. It works, and then it would just always do whatever you want it to do, only when the value is equal to something. So that's something really important. Don't forget this is a double is. So let's cout now. Console out. It stands for console out if you forgot. My value is equal to 3. And then an end line, because otherwise it will not have an enter at the end. So now if you set my value to 3 and run the program again, it will say my value is equal to 3. And if we change it to something else, so let's say 2 again, so it's not going to be in this if statement, and it's not going to be in the else if statement. If we now run it, you will see that it will still call this function, this else statement. It will still say my value was less than 3. Oh, I misspelled that, by the way. But what we can do is we can chain else if statements. So I can type another else if statement, and then this we can check, for instance, if my value is equal to 2. And if my value is equal to 2, cout my value is equal to 2. Oh god. End line. And if we our value is right now equal to 2, but what you will see right now is that it will call that function. So basically what we can do is we can chain a lot of different statements, but there's an easier way to do that. If we want to check each number individually, what we can do is use a switch statement. What a switch statement is you type in switch, then the rounded braces, in that you type the value that you want to check, so in this case my value, and then you use the curly braces to specify, okay, this is the scope in which you're going to check things. Like here I'm going to specify all my different values that I want to check against. So let's, for instance, say let's add a case. A case is something that you want to check against. So we add a case called 2, and then we use a double dots to specify, now I opened it, this is the case, and in here we can type whatever you want. So cout my value was 2, and then an end line. We can do this for, and then we need to specify a break. It's really important, otherwise it will continue the code. Since what you can do is, say for instance you want both 1 and 2 to call exactly, do exactly the same, instead of copying the code. So instead of like having to copy, in this case the cout, you can just type in case 1. So now both case 1 and case 2 will call the cout my value was 2. So if we changed my value to 1 right now, what you will see, it will say my value was 2. Right here, my value was 2, because we did not specify a break. But if I would now type a break here, and I would run it again, then you will say, hey, it doesn't say it anymore. And what if we want something else? Like, do we have to specify it for every single number if we only want to have 2 special cases? So we now have my value was equal to 1 and my value was equal to 2, but what if we I just wanted to say with everything else my value is not equal to 1 or 2? What then? Then we can use a default. So we just type in default and then the double dots, and then we end with the break, of course, otherwise it will run the code. I'll continue running the code, and that's not what we want. We want to stop after after we've done what we need to do. And now we can type cout my value was not equal to 1 or 2, then an end line. So basically what this will do is it will call this default function whenever none of these cases are met. So if my value is not equal to 1 and not equal to 2, you can have up to as many as you want. You can have up to like 1,000 different cases if you want to. But when it's not equal to one of the 1,000 different cases, it will call a default statement. So let's say my value is equal to 0, and we run this code, then it will say my value was not equal to 1 or 2. That's true. Okay, next thing. So I've already done the switch statement because it felt like a good moment. Okay, so the next thing is a for loop. Let's do a for loop. So the way that you declare a for loop is for, and then you use the rounded braces, and then you type some sort of value. So let's just use an int. Let's give it a name. So let's call it index, since that's a useful, a normal name to call it. You either call it index or I. I is short for index. You set it equal to a starting value, so let's say 0, and then you specify do this while this is true. So this is basically a while loop, a different version of a while loop. I will show you exactly the same that you can do the same thing with a while loop in just a second. So now you will specify the statement just like we do in an if statement. So while I is less than, let's say, 5, then we end that part, and then we do I++, since we want to increment I by 1. The I++, you can, by the way, use ++ on every single, oh, this from the last tutorial, every single different variable. The only thing that in this case, so it's equal to, it's the same as doing I is equal to I plus 1 or I plus equals 1. What you can do with counting in C++ is you can specify whatever you want to add or remove or divide by before an is equal to. So what we can do is I divide equals 1, so that means that this is exactly the same as doing I is equal to I divided by 1, or plus equals 1 is equal it's the same as I is equal to I plus 1. So what we do is we do I plus plus, since that's the easiest way to do it. Then we use the curly braces, and then in here we're gonna, let's say, cout the current index is, and then we're gonna push the index in, so we're gonna push in I, and then we're also gonna push in an end line. You can push as many different things into a console out as you want. So what this code will do is it will, let's move it over. It will run this program, will do whatever is between the brackets while I is less than 5. But as you can see, it stops at 4. That's because we specified I is less than 5 and not I is less or equal than 5. So if we do that, and we first close it, and then we run it again, now you will see that will also include the 5. So current index is 0, 1, 2, 3, 4, 5. Okay, the next thing is a while loop. So a while loop is a thing that you shouldn't use if you don't have to. Only use it when you have to. If you can use a for loop or if statements, a switch, whatever, try to not use while loops unless you really need to, for instance for a game loop. So let's say while, let's make something that looks like a for loop, because otherwise it's never gonna exit. So we're gonna create an integer called index. We set it equal to 0, and while index is less than 10, do whatever's in between the next curly braces, so whatever is in this scope. Then the first thing that we're going to specify, or actually the last thing that we're going to specify is while loop, but we're going to type it first, is index plus plus. So we'll increment index by 1, and we're also going to do the cout. My current index is an index, but let's add just an end line here, just so we know that we started the while loop and we're not in the for loop anymore. So we're just going to do a cout, console out, and then an end line. Yes, you can just do that. You don't have to specify any type of string or integer or float, whatever. You can just do cout end line. So what this will do, it will call this function, it will do whatever's in between the curly braces while index is less than 10 in this case. So we'll basically do it 9 times, because index will increment every time, and after 9 times index is not less than 10 anymore. But we could also do while true. This is a really bad statement that you should never do, and you shouldn't run this on your computer right now at home while you're testing it, because what this will do is it's an infinite loop. Like, as you can see, it never stops. It constantly keeps incrementing the current index and printing that out. Eventually this will break because you're out of values. So let's just exit it right now. Okay, let's revert to the previous thing that we had. So index is less than 10, and let's now do a while loop. So we're gonna move this while down here. So we first have the scope, and then we have the while, and now we only have to specify do in front of it. So this means that it will do whatever's inside of this scope while index is less than 10, and now we do need to specify a semicolon at the end. Oh, if it moves it, by the way, it doesn't matter, it's fine. So now it will first do this whatever's in the scope, and then check whether it's true. So we should see something funny right now. Oh no, actually it doesn't. Well, at least this is also a valid way to specify a different loop, a different while loop. This is an old way to do it. I would just use while and then the scope, but you can also do it this way if you really want to. I'm going to get the switch statement. So we're basically through a true it all. So these are the different types of statements that we have. Let's have a little recap. We have an if statement that will only run whenever a certain criteria is met. Then we have an else if statement that will also only run when a certain criteria is met. And then we have an else statement, and that will run whenever some criteria isn't met, or a lot of different criteria, because you have a lot of different else if statements aren't met. And then we have a switch, and this is basically the same as a chain of if else if statements, and an else. So this, we could basically make a switch out of that, but we have to specify each individual number in this case. We can do my value is bigger than 1. Then it will give like squiggly lines underneath the bigger than. We can only do with individual numbers. And then we have a for loop. For loop will basically have a value in the beginning that will constantly be incremented. It's basically a while loop. Like this is the same as a for loop, but a for loop is a nicer way of writing it, since now you need to create a different variable, and like it's basically gonna be specified on at least 2 lines, and it's not as clear as this, since also this index will be always accessible in the main scope, like in the same scope as my value is accessible. While this I can't access this I out here. I doesn't exist, but I does exist in here. So what I does is it's basically a while loop, and it also has the value that you specify to use only inside of the loop that you're working in. So basically only inside of the for loop. And you have a while loop, and it's basically do all this code while something while some criteria aren't met. Oh, and one thing that's also really handy to know is we can have a boolean. So let's do it underneath here. So let's have a boolean called my bool for now, and set it equal to true. There's one extra case that I haven't done in here, but I also want to learn to you guys, and let's have an if statement. So if my bool, then console out my bool was true, and then end line. Like now I think that you might now be wondering like, why did you not specify anything after it? Like, why doesn't it have to be equal to something? If you don't specify anything, at least with bools, like with integers is a little bit different. You should also always specify something. But with booleans, if you don't specify anything, then it will run if it's true. And if you put an exclamation mark in front of it, then it will give you the inverse of what the bool is. So then it will be, in this case, if it's not true, then it will run the statement. And what you can also do is like have a second bool, my second bool, and set it equal to true, to false. And what we can have is, so if my first bool is true, and then you can also add different things. So if my we can add functionality that needs multiple things to be true. We can do a double end, and basically what that will mean is if this statement is true and this statement is true, do the if statement. So if my bool is true and my second bool is not true, then run the statement. So as you can see, this will now run just fine and see out whatever is specified. So my bool is true. But we can also do is an or statement. So so if this is true or that is true. So let's do an or. An or is with double, straight lines, whatever they're called. So let's now do my bool is also not true. So if my bool is not true, or my second bool is not true, what you can see is my bool is equal to true. So this would return false if we only had that. But my second bool is false. So that's correct. So if you now run this code, you will see that this console out is called, like it called my second bool was true. My bool is true. So that's basically it. We can chain up as many as you want, and we can use we can just chain up as many as we want, and everything will just be fine. So thanks for watching. In the next episode I'm gonna learn you all about functions, so yeah, be ready. Hello everybody, in this tutorial I'm going to explain to you how functions work in C++. So first of all, I've created a little document explaining how you declare a function, what the different types of return values are, and a little example. And after this we're going to go into the code and actually make some ourselves. So first of all, the declaration. How do you make a function? You first specify the return type. I'm gonna talk about the different return types soon. Then you specify a name, like what name you want to give it. And then between the soft brackets, you specify all of the different attributes necessary inside of the function. And then of course you end with a semicolon if you're doing a forward declaration that I'm going to talk about soon. Or you don't do that, but you use the curly braces in order to create a scope in which the function will be will be the function. So like in this example, between these curly braces is the function. Everything outside of it, it's not part of the function. Okay, the different return types. Well, the basic return types that you have is, for instance, void, integer, float, boolean, double, or a class, which we're going to talk about next episode, or different kind of things like arrays, which we're also going to talk about soon. And this is a little example. So I've created a function that returns a boolean, so either true or false, and it's called isNumber6. So is this number equal to 6? And you give it a number. And then I have created a little if statement that checks if the number is equal to 6, and if that's true, then it will return true. So the return type, since we've specified bool, we can return true or false. And so in else I'm going to return false. But if this was an integer, so return, let's say, return number plus 5, then we would have to specify then for in this case we would do return number plus 5. So whatever return type you specify, you need to return that to using the return keyword. Just like we had in our main function, I think we had that in the previous tutorials, that we ended with return 0. I might have forgotten that, but that's something that you should always do. Give it return type the main function. But why do we use functions in C++? Well, for instance, if we have a lot of different things, like we have a lot of different enemies that all need to do the same thing, like we all need to check if they're colliding with something, then it's way easier to just make one function that checks collision and then pass in the enemies in the environment, for instance, than to like hard code the like the collision checks for every single one in your main function, since that's going to be a lot of code that is all just redundant, and we can just make a function for it and then a for loop, for instance. So that's one of the reasons why we're always using functions. The other reason is if we're using classes, since classes are highly dependent on functions. Everything inside of a class is accessed via functions, or at least, well, all the things, if you want to do something inside of a class, you have to do it with a function. And more of that will be explained in next episode. So let's now dive into the code. So I've created a little new project in which I'm going to explain to you the different types of functions. So first we need to do of course, the return 0, so we know that there's no error. Always give it a return value. I probably forgot last episode. So let's now create a function. In order to access a function inside of our main loop, we need to specify it above the main loop. So let's create a function that greets somebody. So let's create a void, since it doesn't need to return anything. Void greet person. And then in here I want to specify, let's say I want to give it a string, like the name of the person. So we create an std string, or we can do using namespace std, so we don't have to specify std anymore. So we give it a string, and let's give it a name called, just name, since it's a person's name. And then we use the curly braces in order to open a function. And then in here we're gonna use the console out. Let's do a hi, and then name. then an exclamation mark, and then an end line. By the way, someone in the comments asked me if you could use another function called printf. So I'm also going to give you guys a brief explanation on how printf works. So you have printf, it's a function, standard in C++. You don't need to include anything, I think. Maybe IOStream, but I don't think that you have to include anything. And then between the soft braces, since it's a function, so we have to give something inside of the soft braces, we can specify whatever you want. But there is one fancy thing when it comes to printf. So for instance, we can do print a number, but in printf we can't just do like the push in a number. That won't work. We can also can do plus a number, or actually it will work now, but the fanciest thing that you can do with printf is you can give it a comma, so specify it as a second parameter, and then inside of here we can use %, and then whatever type it is. So let's in this type is an integer, so we use an I. You also have an F, and I think you also have a B and a C for character. So in this in this case it's an I, so we use an I, and so now it will replace the %i with whatever we specified. And what we can actually do right now is still type after this. So now it will just replace this %i with the 4 in this case. So it's a pretty fancy function, but I like the cout, so the console out a little bit more, since it's easier to use. So you can do it with printf if you want to. That's no problem. Okay, so now we've created our function. So let's now greet someone. So we call the function by typing in a name, greet person, and then we specify a name. So it's a string, so we use the double quotation marks. And let's give it a name. Let's think of a name. I've got Link on the wall, so let's say Link. And then if we run the program with Ctrl F5, it's the first time that's building it, so it always takes a little bit longer. Then you will see that it says hi Link. Okay, so we have a function, so let's now create another one. Let's say we only want to greet specific people and otherwise like not greet a person. So what we can do is we can create a new function. Let's give it a bool. Make it a bool return value, like 1 to greet, and then once again a string name. So now between the curly braces, we're gonna have I think a switch. Let's make a switch. Or can you not have a switch with? No, you can't have a switch with strings. That's because it's a class. You can't have a switch with it. So we need to use an if statement and else if statements. So if name is equal to, let's say Link, because we want to greet Link, then we return true. Else, let's just create an else for now, return false. So what we now can do is we can create an if statement with inside of that want to greet, and then in as parameters Link. So if you now move greet person into here, we will only greet the person if the name is specified as Link. So as you can see now it says hi Link, but let's change this to Bob. We don't want to greet Bob. Bob is a bad person. I'm sorry if any of my viewers is called Bob. It was just an example. But as you can see now it doesn't greet Bob. But let's say Bob is also nice, so we're gonna add an else if statement here, and that its name is equal to Bob. Then it will also return to true. So now if we call this function again, it will also greet Bob. But hey, what is this? I want my main function to be a little bit at the top. I don't want, if I have a lot of different functions, to scroll all the way down just to get to my main function. There is a way around that. What we can do is we can forward declare a function. So what we're going to do first is we're going to take this entire function, we're going to copy it, or I use Control X, and then we're going to paste it down here. But in order to make this work, what we need to do is we need to copy the first part, so the bool want to create string name, so whatever the function is, what it returns, and what attribute it has. We need to copy that, and we need to paste that up here with a semicolon at the end. So now, and only now, we can use this function properly. Otherwise, it might give us errors, and it might be weird. It might do weird stuff. So use the forward declaration if you are using a function, for instance, in your main file. So we're going to do the same with greetPerson. And now we can run the program again, and as you'll see, it will still work. So we're going to greet Bob. Okay, so now we've forward declared functions, we've created functions. Let's now create a function that depends on a function. Yeah. So let's create a function, for instance, a void called autoGreet, and it takes the string name. And what this function will do is, first of all, actually we have to copy it so we can create it down here. What this function will do, it will call an if statement with with one to greet with a name, and then if it's true, it will greet a person. So basically what this function does is a wrapper for this if statement. Such functions are going to be really handy when we're going to work with classes and we're going to do stuff like give enemies health, but we only want it to be able to see the health and not to be able to modify the health outside of the class. Then we can use some sort of function, a sort of wrapper that returns the value of the health, a copy of the value of the health, so it doesn't return the health itself, so it's not modifiable. Okay, but let's now go into our main function and call autoGreet on Bob. We're also going to call autoGreet on Link, and let's also call autoGreet on Jack. Oh, not Jack. Okay, if we now run this program, you will see that it will greet Bob and Link, but not Jack, because we specified that we only want to greet Bob and Link. So this is my tutorial about functions. I hope you learned something about it, and next episode we're going to talk about classes. So be ready for that. Hello everybody! In this episode I'm going to talk to you about classes in C++. Why do we have classes in C++? Well, because C++ is an object-oriented language. So what you have to do is object-oriented programming, which stands for OOP. And the way that you do object-oriented programming is by creating objects, and the way you do that is using classes. So how do we define a class? How do we declare one? We first specify it's a class, and then we give it a name, and then using curly braces we specify that everything inside of this is inside of a class. Two things that a class always has, whether you've specifically set that whether you specifically want to change it or not, is a constructor and a destructor. A constructor will be called whenever a version of the class, an instance of the class, is created. So this function will always be called whenever the object is created. And a destructor will always be called when object gets out of scope or gets deleted. So then you can do some cleanup code to delete some variables that you need to delete or reset some things. One thing that a class is going to have is member variables. Those are variables that differ per instance of the class. So for instance, we have 4 different enemies, and they all have their own version of health. It's all called health, the variable is all called health, and it's all the same type, but the values can be different. Then we have the different type of specifications that you can do to change how the variables and functions can be accessed. We have the private keyword, we have the public keyword, and we have the protected keyword. Private means that only and only these functions and variables can be called inside of this class. So only this class is accessed. Public means that everyone that everywhere that this class is created and everything that has access to the class can also get access to this variable or function. So basically our main functions that we want to call from our main program should be public. But our variables like health and money or whatever, or lives, all need to be private because we don't want our main program to change it. Then we also have the protected keyword. I'm not going to go into detail on the protected keyword just yet. I'm going to do it in a later episode when I'm going to talk about inheritance. So when we're going to talk about having a class that depends on another class. I know it sounds crazy, but it's going to be something. Okay. So here's a little example of how to create a class. So I specified first that I wanted to be a class with the class keyword. Then I gave it a name, my class. Then inside the curly braces is the scope of the class. So everything that's specified between these curly braces is going to be a part of the class. Then I started with the public keyword. This is really important. Otherwise, we cannot create one since we cannot create an instance of the class since the constructor is private. So only this class can create this class, and things are going to be messed up. So I've added the public keyword, which we need to end with a double dots. Then I've created a constructor. The way that you know it's a constructor is because it is the exact name of the class without anything in front of it. So no specifier return type. And the destructor is exactly the same as the constructor, but with a tilde in front of it. If you don't know where the tilde is, it's underneath the escape key next to the 1, and you need to access it using shift. Then I've created a little function called a void function, so it doesn't return anything, called doStuff. And then I've created some private variables. So I specified the private keyword, and then I specified the variables that I want to have. So let's say I've created an int called important value because we needed something important, and a boolean like should do stuff. Okay, let's now get into the code and actually make a class. So let's head over to Visual Studio. Oh, I still need to create my main file, so let's do that quickly. Main.cpp should include iostream, oh god, and string. We're always going to need those. Then we're going to also use using namespace std, and then a void, an integer main, then return 0. Okay, so this is our main file. Nothing important is going to happen here yet. The one thing that we're going to do is we're going to press right click on the project. So as you can see here in the Solution Explorer, it might be on that side for you. I always move it to the left side. I find that more useful, but you can just grab the top thing and then drag it around. So it's probably on this side for you right now, but I just dragged it over to this side. Okay. Okay, so what we're now going to do is we're going to press right mouse button on tutorial 04 in my case, but whatever your project's name is. And then we're going to do, go to add class. We're going to select the C++ class. And now we can give it a name. So let's create an animal. So then we type in animal, or our class name. You can make whatever class you want, but I'm going to make an animal. And as you can see, we can specify some other things here, like a base class, That's for inheritance. We're going to talk about that later. Access, public. You can check. You can select whether everyone should be able to create an animal, or only an animal should be able to create an animal, or only inherited classes of animals should be able to create an animal. So we're just going to select public, since we just want to create an animal everywhere if we want to. The CPP file and the H file are all just fine. We don't need a virtual destructor, and it doesn't need to be inline. We're going to talk about this later in a later episode. We're first going to just talk about basic classes. Then we hit finish, and now we've created a class. So as you can see, we have an animal.h file, which contains a class, then the curly braces, public, and then the constructor and the destructor. But we also have a CPP file. Why do we also have the CPP file? Well, when it comes to classes, it's really important that you create the functions outside of the header file. A header file should only be, the .h stands for header. A header file should only be used to like specify things. So for instance, specify the different functions that you have, the different variables that you have, and the actual code, unless it can't be inside of the CPP file because of special reasons that we're probably going to get to in a later episode. You need to write the code itself inside of the CPP file. Okay, so now we have our animal class. So let's create an instance first in our main function. But if we just type animal on here, we're not going to see it. Why do we not see it? Do you remember that I said there were two different types of includes? We're now going to need the second type. So we're going to do a pound include, and now we're going to use the double quotation marks, and as you can see, we can see animal.h there. So what we're going to do is we're going to type in animal.h, or click on it if you want to, and then we're going to include the animal class. So now we should be able to type in animal and create an animal. So now we've created an animal, but this animal does not contain anything unless a destructor, and we don't want to call it a destructor yet. By the way, destructors will automatically be called whenever something gets out of scope. So when it comes to the main function, it will be automatically called whenever the main function ends, so whenever it returns 0 or whatever error code we had. Okay, so let's now create a function, a public function. It's going to be a void, and let's call it make sound. We don't need to specify anything yet. It doesn't need any attributes, because we're just want to make sound. It doesn't need anything specific for that. And let's also make a private. So we're going to specify the private keyword string called sound. As you can see, string is not available, even though we've included string and istream in here, and even did using namespace std. But we haven't included them in this header. These includes are only gonna work in something that in basically the file itself, unless you've basically only in the file itself for now. So we need to do the includes again. So we need to include string, and we need to include iostream, which you want to be on top because it's the longer one. And then we also need to specify using namespace std. So now we have a string called sound, and we have a void make sound. But why does it have a weird green squiggly line underneath it? That's because it isn't declared in here. The constructor and the destructor are declared, but the sound isn't declared. So what we can do is either go in here and type animal double dots and then make sound. We can either do it like this, or we need to specify the type, so it's a void. This works just fine. Or what we can do is we can right mouse button on the squiggly line thingy, then press quick actions and refactorings, and then create definition of make sound in animal.cpp. And as you can see now, there is a declaration now, the same as we just typed. But if this weird thing comes, like this weird blue things, that means that you're inspecting a different file from within a file. You can either just press escape to close it, or if we go to peak definition again, or we can press the promote to document thingy to open the document itself, and now it's also gone. Okay, so now we've created a function. We're just going to use a simple console out and then sound, and then we're going to use an end line. But our sound is currently specified to nothing, like it doesn't contain anything. So we're going to go to the constructor, since this will be called first. And what we're going to do in the constructor is we're going to say sound is equal to whatever sound we want to have. So let's create a sheep. So it's going to be, can I do that thing on my computer? No, so just a meh. Then the cow would work better. So boo. So we've created a sound, and now from within our main function we can call animal.sound, make sound. But as you can see, we cannot find animal.sound. The sound is invisible. We cannot access it through the through the dot which we normally use to like find things inside of classes. But we can find it inside of the class itself. So if you run this function right now, this program right now, you will see that it will say moo. Boo. Oh, I said boo. It needs to be moo. Sorry. Moo. It's a cow. A cow doesn't say boo. It said moo. Okay. So for cow, and it says moo. So what you can also do is, this is going to be a preparation for the next tutorial in which we're going to explain inheritance, is we're going to also add a string called name. And we're going to do the same in the constructor. We're going to do name is equal to cow. And in make sound, we're going to add, oh, wrong one. We're going to add a few things. So we're going to add name, and then double dots and a space. So it will say the name of the animal, then it will do a double dots and a space, and then the sound. So if you now run the program again, you will see that it say cow moo. So this is basically an explanation of classes. Let's go over it again. So in order to create a class, we go to the project itself, right mouse button on it, add class, C++ class. We're going to specify the name. Nothing else is important right now. You only need to type in a name. Press finish. Then I will create a class for you. You need to do your includes again. So if you need iostream or string, you need to include them again. And then you have the public keywords, and that will specify whether something should be accessible outside of the class. You have the private keyword. That means that it will only be accessible inside of this class. And then you have also an extra keyword called protected, and it will mean it will only be visible in inherent classes. What we can do inside of classes is we can make functions, like we learned last episode, and we can make variables, like we learned in the first episode. And one thing that's really important in classes is, just like you had with forward declaring functions inside of your main function, so you would make we would declare a function here and then type the rest down here. We need to do the same with classes, but we need to declare the functions inside of the header file and then type the code inside of the CPP file. And that's basically it. So thanks for watching, and I'll see you next time. Hello everybody, and in this tutorial I'm going to explain to you inheritance in C++. So first of all, what is inheritance? Well, inheritance is a really useful concept. It basically means that you're using one base class, then you derive a different class from it, which basically contains all of the data from the base class, but adds more specific things to it or change some things around. For instance, let's say we want to have a lot of different enemies, but they all have the same basic functions. Then what we can do is we can create a base class called, for instance, enemy base, and then make all of the other enemies inherit from it. So how do we declare inheritance in C++? Well, what we do is we type in class, the name of the child class that we want to create, so the class that's going to be inheriting from another class, double dots, the public keyword, and then the name of the class we want to inherit from. I've created this little example, so I've created my base class, so just simply class, base class, with a public constructor and destructor, and I've created another class called child class, with the double dots, then public, and then base class. So as you can see, we're literally just using base class here, since that's the name of the class. So now we can use whatever is inside of base class. But now we're going to go to code, and I'm going to show you what I can do using the animal example of the previous episode. So here we have our main function. We've created our animal, and we've called the make sound function. But let's say we want to make another animal which has a different name and a different sound. Since right now I've set name to animal and sound to no particular sound. So first of all, we need to create a new class. How we do that is we go to the project, not the solution. It's really important that you go to the project. Right mouse button and then class wizard. That will open up. Then we'll press add class. The class name, let's create a mouse. And then here in base class we type in animal, since that's the name of our base class. Make sure that any capital letters are of the letters in the same size, so everything that's a capital letter needs to be capital letter, everything that isn't needs to be a not capital letter. So base class is going to be animal. And then we create finish. Let's also, for instance, create a cat. So I have a mouse and a cat. As you can see, I just forgot to put in the base class. So one thing that we then can do is we can define it by ourselves. And we can just define it the same way that we did right here. So class, child class, double dots, public, the base class. So now we have our cat, and it needs to inherit from animal. So then we use the double dots, public, and then the name of the base class, so animal. But as you can see right now, you have a squiggly line underneath animal. How can we fix that? What we need to do is we need to include the file. So we need to include animal. And as you'll see right now, that will fix it. And when you create inherited class from the class wizard, it will automatically include animal for you. I'm just going to do a little formatting so it will be a little bit nicer. So what we can do right now is we can go to the constructor of the mouse class, and in there we can change the name and the sound that the animal makes. But one thing that we need to make sure that the animal has, and that is that all the things that are nested to private that we do want to change inside of a child class, so for instance the mouse, that needs to be set to protected. That means that we still can't access it from outside of the class, but that all of the child classes can also modify it. So this needs to be changed from private to protected. So now when we go to the mouse.cpp, we can change the name to mouse and the sound to, let's say, peep. So now if you run the program again, but instead of using an animal, we use a mouse. The mouse just got animal. So if you now run it, as you will see, it will now say mouse peep. Even though in animal, the .cpp we specified name is equal to animal and sound is equal to no particular sound. We modified it inside of the mouse constructor. Let's do it also for the cat. So the cat, the name will be cat, and the sound will be meow. So now what we can do is we can also include cat, with a capital C, and also create a cat, just a cat called cat, and then we can also call the cat make sound. And if you now run it, as you will see, it will say mouse, peep, cat, meow. So basically what we're doing right now is we're calling a function from the animal class while using the variables that we changed inside of the constructors of the cat and the mouse class. That's what inheritance can do. It can make it so you can easily modify values while still using the same functions that you were using with the base class. Thanks for watching, and in the next episode I'm going to explain to you virtual functions. So be prepared. Hello everybody, and in this tutorial I'm going to explain to you virtual functions. So what is a virtual function? Well, let's say that we have inheritance. So we have a base class, for instance an animal, and we have a function that we want one of our child classes to modify because a child class might behave differently. So let's say we have an animal with a move function. The basic move function will just slowly move something around, but a cat and a mouse, they will both move around really quickly. So what we can do is we can use variables for that and modify the variables, but what might be easier to do is just override a function. So how do we override a function? What we do is we specify the virtual keyword in front of a function. So all we have is virtual, the return type, the function name, and then between the soft brackets all the attributes that we need. So as an example, we have a virtual void called update with a delta time. And the only thing that specified that it was virtual so that we can modify it, that's the virtual keyword. Then we also have something different, something called a pure virtual function. What is a pure virtual function? A pure virtual function is a function that needs to be overridden by a child class. The class cannot work without it being overridden. So basically, the base class that you have, you cannot create it because it has a pure virtual function. So it has a function without any definition. You need to create a definition externally. How do we declare a pure virtual function? Well, the same way that we just declare a virtual function, only with an is equal to 0 at the end. So let's now dive into the code and actually create some virtual functions for ourselves. So here I am again with a cat and mouse example from last episode, and let's now make the makeSound function virtual. So the first thing that we're going to do is we're going to go to the animal.h file and we're going to specify virtual in front of the makeSound function. Virtual void makeSound. Okay, what we're now going to do inside of the animal.cpp is just copy this and remove it. So a basic animal will not make any sound. It will not do anything if you call a function. So let's now go to the cat.h, for instance. And then under the public keyword, we're going to specify a void called makeSound with no parameters. And what we're going to do is we're going to type override. This is important. This will specify that we're going to override the function that we had and then end it with a semicolon. Then we're going to create a declaration and simply just paste it in here. And then we're going to do the same with mouse. So we're going to type void makeSound, no parameters, override. And we're going to create a definition too, and we're just going to paste it in here. So what we're going to do right now is in the main.cpp file is once again include animal. And now we can just create an animal, so let's just change this back to animal. And then also create a mouse. And then also call the mouse.makeSound function. So now if we run the program, as you will see is we're just going to see the cat and mouse. So we're just going to see mouse, peep, cat, meow. We're not going to see anything from the animal. That's because in the animal.cpp file, we specified that makeSound doesn't do anything. To further show you that this actually works, we're going to modify the mouse function. So let's say we want the mouse function to also end with an exclamation mark because we want the mouse to be really aggressive. So as you can see right now, it says mouse, peep, exclamation mark, and cat, meow. So that shows us that it will call the correct function based on what class it is, because we made the original one a virtual void. So let's now make a pure virtual function. How we do that is we specify is equal to 0 at the end. So now we need to delete the declaration of animal.makeSound because it's a pure virtual function, so there can be no definition inside of the base class. So if you now go back to main.cpp, you will see that animal has a squiggly line underneath it, and it will say object of abstract class type animal is not allowed. Function animal makeSound is a pure virtual function. So what this means is we cannot create a base animal anymore. We need to create an animal of a specific type. So if you just remove anything that has the animal in it right now, And if we run it again, what you will see is it will still just call the functions that we've created earlier. So the mouse, peep, with an exclamation mark at the end, and the cat, meow. So what we've learned right now is what a virtual function is, so how we can override a specific function, and we've learned what a pure virtual function is. So how we can create a function that needs to be overridden. This is really handy if you want to have, for instance, different animals or different NPCs that all behave differently on, let's say, for instance, walking. That all walk differently. But you don't want anybody to be able to just create an animal, like a pure animal or a pure NPC. They need to be an NPC of a specific type. Then we can use pure virtual functions. So we can specify that we need specific behavior that's different from all the rest for this specific class. That was it. Thanks for watching. And in the next episode, I'm going to explain to you what arrays are. So be prepared. Hello everybody, in this tutorial I'm going to explain to you what arrays are. First of all, why do we need arrays? Arrays are really important when it comes to, for instance, having a map. Since you want to store that map, you want to store every different tile that you have. So what we then can do is we can create a 2D array, which is an array which contains arrays, for instance integers, which contains the type of tile that it is. But what we can also do, and what we're going to do for this example, is have an array of friends. We want all of our friends' names. We want to be able to just check the array and see all of the different friends that we have. So how do we declare an array? We first have the variable type, just like we do when we normally declare a variable. Then we have the name, just like we do when we normally create a variable. Then we use the square brackets with inside of that a size. And if we do this and then use them with a semicolon, then we will have an array with none of the values already specified, so it will just be random values. So what we can do is we can have the variable type, then a name, then between the square brackets the size again, so exactly the same as we had before. But now what we're going to do is we're going to use the curly braces, and then in there we're going to specify all of the different parameters based on the variable type. So for integers you're just going to type integers, for floats we're going to type integers with dots and f's at the end. For doubles we're going to do, without the f basically. For characters we're going to use the single quotation marks. And for strings, we're going to use the double quotation marks. So basically that. So here for a little example. So let's create a string of friends. So we have a string, friends, which contains 5 friends, since we specified a size of 5. Now we're going to create another one, also called friends, with the size of 5, but now we're going to specify their names. So Alyssa, Jacob, Josh, Daniel, and Brittany. But how do we access something inside of an array once we've created it? We're going to use the same square brackets again. So we type in a name, and then we use the square brackets, and then the index. Make sure though that your index is never bigger than the size of the array, since that will result in unexpected behavior. And one thing also to note is that counting always starts with 0 in C++. So you have 0, 1, 2, 3, 4, and that's basically all of the indexes that you can have for an array of 5. So it's not 1, 2, 3, 4, 5 like you would guess that it would be. No, it's 0, 1, 2, 3, 4. So as an example, here I just access the name of a friend, and here I simply print out the name of the friend. So let's now dive into the code and see it in action. Okay, now with our Visual Studio we can create an array. So let's create an array of strings. So you type in string, it's already specified using namespace as city. Create a name, so call it friends, and then we're going to specify a size, let's say 5. So now I want to give it a value. So let's use the square brackets, and then in here we're just going to give it some empty parameters, just so we know that we have exactly 5 of them, and then with a semicolon. Okay, so now we can give it the value. So let's use the same that I used in example. So I have Alyssa, Jacob, Josh, Daniel, and Brittany. Okay, now that we've specified all the names of our friends, what we can do is we can make a little for loop
to print out all the different names of the friends that we have. Let's create a for loop. For int I stands for index, it's equal to 0, I is less than 5, because we have 5 friends in an array, a semicolon again, I plus plus, so I plus equals 1. And then in here, we're going to do cout, push in there, friends with the index of I, so with the index of index, and then we're going to also push in an end line. So now if we run this program with Ctrl F5 so it breaks at the end, as you can see it will say Alyssa, Jacob, Josh, Daniel, and Brittany. So using the 0, 1, 2, 3, 4, we access all of our different friends. Our friend at 0 is Alyssa, friend at 1 is Jacob, friend at 2 is Josh, friend at 3 is Daniel, friend at 4 is Brittany. So let's now talk about the 2D arrays that we had. What is a 2D array? Well, it's basically the same. So let's now use an integer. So int called our map. So we're going to create a map for a level, for instance. And then in order to make it a 2D array, we're first going to specify the first size of the array. And then we're going to specify the second size of the array. So now that we have a 2D array, how do we initialize it? Well, there are two ways that you can do it. We can either use the square brackets technique, but how do we do that for a 2D array? Well, what we do is we use square brackets for each of the array things. So for each array inside of the array. So basically I've created 5 arrays inside of the array. So what we can do now is specify, let's make the first one 0, 1, 2, 3, 4. Second one we're going to have 5, 6, 7, 8, 9. Let's start with 0 again, but this one already contains 5, so let's do 0, 1, 2, 3, 4 again. So in here have 5, 6, 7, 8, 9 again. Then in here, let's just have some random values. So 4, 6, 3, 8, 9. And space them out evenly. One of the easier ways to note this when you're using a 2D array is to actually make it 2D. So what we can do is we can simply break the line and then use tabs to space it out evenly. And do this for every single part of the 2D array, so now you can actually see that it's a 2D array. So how do you print everything inside of a 2D array? Well, that's actually pretty easy to do. What we're going to need is 2 for loops. So we're going to need a for loop which contains an integer called y, so we set it equal to 0. And why do we need y first and not x? I think it was xy, right? That's correct. That's how we know that when we're just saying xy. But when it comes to 2D arrays, if you just look at it, what you will see is that you will first have the different arrays that go like that, since you go like down scopes. So the first scope is the scope of these curly braces. And as you will see, everything inside of here is noted down. The 0th parameter, the first parameter, second parameter, third parameter, and fourth parameter. And then the second part, so the second array, is inside of these curly braces. So the 0th parameter, first parameter, second parameter, third parameter, fourth parameter, and so forth. So we first need to access the y coordinate. So for y is equal to 0, y is less than 5, because we specified the size 5, y plus plus. So now we're going to create another for loop for int x is equal to 0, x is less than 5, x plus plus. So now in here we're just going to do a simple cout map y x. Notice that I don't do an end line here. That's because I want to do the cout end line out here, because otherwise it would end the line after every single number. So you would 0 and 1, 2, 3, and 4 would all be on its own line, but we want them to all be evenly spaced out. Like we want them all to be in a row because they are in a row in an array. So what we do is we do the integer and the end line on different lines. So we first do all of the integers that we have here, and then we do the end line. But one thing that can make it look nicer is also push in a simple space. So if you now run the program again, as you will see, we'll now have all of our different values printed out. That's basically all that I can explain to you about arrays. So thanks for watching, and in the next episode I'm going to talk about vectors, a special type of array. So be prepared. Hello everybody, in this tutorial I'm going to explain to you vectors in C++. So what is a vector? Right now when we've used arrays, they all been of a static size. We all specified the size of the array. But what if we don't know what the size of the array is going to be? For instance, we don't know how many different animals we're going to have in our game. We don't know how many different enemies we're going to have in our game. We can't just use an array because that would specify a size, so it will always be an X amount of enemies. So what we can do is we can use a vector. And basically what a vector is, it's a resizable array. It's an array without a specified size. We can always change that. How do we declare a vector? What we type in is vector, then we use a smaller than the variable type, then a bigger than, and then the name of the vector. So basically we're declaring a variable with vector in front of it and the square brackets around the variable type. So in this example, I'm once again going to use friends. I've created a vector of strings called friends. But how do we add something to a vector? Well, we use this little function that a vector gives us called pushBack. And then we specify between the soft braces what we want to push back. And how do we access something inside of a vector? Well, we simply do it the same way as we do in an array. So let's now dive into the code and see what happens. Okay, now that we're in our main.cpp file, we need to include one thing first. We need to do pound include, and then we need to include a vector. Otherwise, we're not able to use vectors to their fullest extent. So let's now create a vector of friends, so a vector of strings with our names. So we're going to type in vector. Normally we'd have to do std vector, but I've used using namespace std to get rid of the std namespace. We're going to create a vector of string. See that also included string, and then we call it friends. So let's now add a few friends. So what we're going to do is friends.pushback. Let's do Jack. Friends.pushback David. Let's do one more. Friends.pushback Annie. Okay, so now we've specified all our different friends. So let's now print them all out to the console. So we're just going to create a little for loop. So for int I, which stands for index, is equal to 0. I is less than, and this is a little bit different in vectors. We don't have to specify a number here. We don't have to type in 3 because with 3 different friends, we can use something very specific that a vector has. Friends.size. So the vector name .size, that will give you the number. So in this case 3, but if we added one more friend, it would be 4. And then I++. So this basically makes sure that you will loop over every element inside of the vector without having to specify or hardcode a number. So what we now can do is do a console out friends I, and an end line. So if we now run the program, as you will see, it will say Jack, David, and Annie, which are the friends we specified. Well, let's add one more friend. One more friend that we sort of have, but isn't really a friend, but that needs to be on the official list. This is going to be the official list, and then we're going to remove the friend and give an actual list of our friends. So let's create a friend, friends.pushback. Let's call him Tim. So now if we run the program, as you will see, we'll say Jack, David, Annie, and Tim. But there's one more little function that we can do. What if we don't want to use a specific friend anymore? What if it isn't a friend anymore? What we can do is call friends.popback. What this will do, it will remove the last friend that we specified. So basically, right now, Tim is going to be the last one, since he was last added to the vector, so Tim will be removed. So if we copy this and do the for loop again at the end, if we now run the program, what you will see will say Jack, David, Annie, Tim, and then Jack, David, Annie. What if we don't want to remove someone at the end of the vector, so we want to leave Tim, but we want to remove someone that's more in the middle, for instance, David? What we then need to call is a function called swap. So just type in swap, and then what you need is you need 2 different operators. What we're going to do is we're going to call friends, and then we're going to specify the index of David. So this is going to be 1. Remember that you always start counting at 0, not 1. And then we're going to use friends.back. Basically what this does is it will swap the values. But why do we use .back and not a specific index for this? Well, what that back does, it basically always returns the last element in the vector. So it will basically return Tim right now. Now that we've done that, we can simply just call friends.popback. So if you remove this friends.popback and simply keep this swap, friends1 and friends.back, and then called popback, what you will see is that we have a vector which still contains Tim, but it contains Tim at the second place that David used to be. That's because we swapped David and Tim and then removed David. So that's basically everything that I have to say about vectors right now. In the next tutorial, we're going to talk about pointers, so be prepared.
Hello everybody, welcome back to another C++ tutorial. In this tutorial, we're going to talk about pointers. In the last episode, I explained to you how memory works when it comes to pointers. In this episode, I'm going to explain to you how you actually create pointers in C++. First of all, how do you create a pointer? Well, that's actually pretty simple. You just type in a variable name, so for instance, string. Then you type in an asterisk or a star, and then you type in a name that you want to give it. So let's just call it name. This creates a pointer. There's only one problem when it comes to memory in C++. And that is that it's no default value. The default value is just the value that it previously was, so it just takes the bytes and that's the value. So every time that we run this program, name is going to be something completely random. It's going to point to some random memory. But we can fix that. We can use something called noPointer in order to specify that this pointer is supposed to point at nothing. The way that we do that is we simply type in is noPointer. And basically what it does is it sets a memory address of name to nothing, so that is 0 in most cases. The next thing that we need to know is how do we create memory on the heap? Well, we simply use the new keyword. So in order to create a new string for name, we type in name is equal to new string. And then in here we can specify whatever we want the starting value to be of the string. So let's say Jack. So now we've created a new variable in the string. One thing that you always have to do as soon as you create something on the heap is instantly create the delete function too. Otherwise you're going to get memory leaks and that's bad. So how do you delete something from the heap? Well, you simply type in delete and then the variable that you want to delete. So name in this case. But it's always handy to have a failsafe. So first check if it isn't already noPointer, because you're going to get an error if you try to delete something that's null. So if name ain't equal to noPointer, then delete. This way you will not delete something that's not there, so it won't give you any errors. So let's now print out a name. So we're just going to use cout name end line. So let's now run the program, and what you will see is that we get a really random value. This is not Jack. This is not what we said it would be. No, what it's printing out is the memory address, because the only thing that it's saved on the stack is the memory address that points to the actual value on the heap. So this simply prints out the memory address that is saved on the stack. So if you run the program again, you will see that the address is different. In order to prove that is actually the case, we'll simply just comment out this line of code. So the name is equal to new string Jack, and now if you run it, you will see that the memory address is null. That's because we specified name is equal to noPointer. So how do we then actually access a variable in the heap? Well, we simply use the asterisk character in order to get the memory on the heap. So now if we run the program again, you will see that it actually says Jack. And that's basically all I have to explain for this episode. In the next episode, we're going to talk about references, so be prepared. Hello everybody, and welcome back to another C++ tutorial. In this tutorial, I'm going to explain to you what references are in C++. So first of all, what is a reference? Normally, when you, for instance, have a function and you pass something into the function, you cannot modify it inside of the function. That's because you're not passing in the actual variable, you're passing in a copy of the variable. But using references, we can actually pass in a variable so we can modify it, and if we have really big classes, for instance, then we don't have to copy it every time. So there are two things that I'm going to explain to you. The first thing is a reference. The second thing is a constant reference. Both of these are really important. A reference is important when you want to edit something inside of a function, and a constant reference is important when you have big variables, for instance big strings or big classes, and you don't want to copy them every time because it's just going to take up more memory. So how do we specify a reference? Well, let's first create a function. So let's simply call it void change name. And then in here we need to specify a string. So let's just call it string name. Let's not give it a body yet. Let's go back to change name. Now it's time to specify a reference. The way we specify a reference is with the AND character. So just like we did with pointers, we simply put it in between the type and the name, and that will make it a reference. So now if you create a string here, called name and set it equal to something, so let's say link, and if we call a change name function with name, so in here we specify, for instance, that we want to change the name. So let's for instance say name is equal to Zelda. And if we cout it at the end of here, so console out it with an end line, and if we run it now, you will see that it couts Zelda instead of Link. That's because we modified name to Zelda instead of Link. But if we would remove the reference key and we run it again, you will see that it says Link, even though we changed name in here. Well, we actually did change name in there, but we did not change the original version of name, we changed the copied version of name. So as you can see, it can be really handy to use references. So the next thing that we're going to do is let's create another function, void say name. And in here we're going to pass in a constant string at name. Do you see the difference between the two functions? In here I did not specify const in front of it, but in here I did. What this will do is it will make it so we cannot modify the string or whatever variable we pass in, but because it's a reference, we're also not going to copy it. It's a really good coding practice to use constant references because it will save quite some memory when you have a big program with a lot of different enemies, for instance, a lot of different objects. So it's really handy to use this. And now in here we'll simply, just move this line of code and then call the say name function. Now if you run a program, you will see that it's still cout Zelda. But if in here we would say name is equal to link again, then you will see that you will get an error. It will give you a squiggly line underneath the is. That's because this is constant, we cannot modify the value. So it's a really good way to know that a variable is safe. You know that it's not going to be changed, but you're also not going to copy the data. Another thing that you cannot do, for instance in the say name function because it's constant, is pass it through to another function and use a non-constant version of that variable. That's because once it's constant, you cannot change it back to non-constant. You have to go up a few scopes to a point where it was not constant, and only on that point you can send it to something that needs a non-constant version of it. That is just to keep it safe. That's just so you cannot modify something that's constant. So if we try to call the change name function here, with this version of name, you will see that you also get a squiggly line. That's because it's a constant version and you're trying to pass it through as a non-constant version. So it's not possible. That's basically all I had to say for today. I thank you for watching and I'll see you next time. Hello everybody! In this tutorial I'm going to explain to you the different types of memory that you have in C++. The two different types of memory that you have are called the heap and the call stack, commonly referred to as the stack. The difference between the heap and the call stack are that the heap is bigger but slower and the call stack is smaller but faster. Basically the call stack is the memory that you use whenever you declare variables the normal way, so like you've been doing thus far. But sometimes you need variables that are bigger or contain more data than you can store on the stack, and that's where the heap is for. The heap is basically a memory pool that's normally not accessed. You need to specially access it using something called pointers, which I'm going to explain to you in the next episode. One big note when it comes to variables on the stack and the heap. Variables on the stack get destroyed whenever the program ends, but variables on the heap don't. Variables on the heap need to be manually destroyed. So let's now go to a visual example. So here in a visual example, the black row represents our memory on the stack, and the gray row represents our memory on the heap. Up here we have our different variables. The variable yellow, which might represent for instance a string, contains 5 memory blocks, red 6, which might be a class, and then we might have an integer, and then another float with the size of 4 memory blocks, and then maybe another class with the size of 8 memory blocks. So if you allocate all the memory on the stack, then you will see that if we allocate all of them, we will run out of memory, since I'm still missing 1 memory block for the 8. And this happens quite a lot on the stack. And the error that you then get is called a stack overflow. That means that you've used all of the memory on the stack. But how can we solve this problem? What if we need more memory in order to make a program run and our computers are fast enough and have enough storage in order to actually give us all the memory that we need? What we do then is we use the heap. So we store our variables on the heap. So let's first make all of the allocation undone on the stack. And let's now allocate our memory on the heap. What you can see now is that we actually haven't run out of memory. We could store all of the data without any problems. But right now we wouldn't be able to access the variables in our program, since our program can only access things from the stack. So what we need in order to access something from the heap in our program is a pointer. What a pointer basically is a memory address. So it contains the beginning of the memory. So in this case, if we allocate a pointer for yellow, then it will point to the first memory block, since that is the beginning of the data for yellow. And then if we allocate a pointer for red, it will point to the 6th memory block, since that's the beginning of red, and so on and so on. So as you can see, we saved a lot of memory just by allocating things on the heap, and using pointers in the call stack. We saved up a whole lot of memory that we can now use for other variables. There's only one problem though. It's not a big problem, actually like a tiny problem, but pointers are always slower since you're pointing to memory that's basically not normally accessible by the program. It needs to specifically ask for the memory. Let's for instance say you're at a bookstore. You can either pick one of the books that's already there, and you will get it really quickly, Or you can go to one of the computers and order one of the books that you really want, but it's going to be slower, but it can be whatever you want. It's the same with the heap and the stack. The stack is basically the store. You can get whatever is there, but the size is limited. You only can choose out of a limited amount of books. But the heap is everything what you want. You can store whatever you want there. You can buy whatever you want there, but it will take longer for you to get the book. But this is not always something that you should worry about. Let's for instance say you have a variable amount of enemies. You don't know how many can be, but it can be more than what a stack can handle. And it's better to allocate all of the different enemies on the heap, even though you might be able to store them on the stack. So it's kind of this balancing act of quantity over speed. That was basically all I had to say for today. So thanks for watching, and I'll see you in the next one.